and also they will have a peer groups. They also have a 4-byte AS and so on. They have a lot of different advanced features we need to go in through, and how we're going to use all these features and technology to improve our network performance. So at the first place, why we need to use all these protocols? Why we need to using these features? So definitely they will have a reason why they need to be used and how these features improve our network performance. And last, how the possible on the troubleshooting for the BGP network. Yesterday, actually, we go through a bit on the troubleshooting. Let's say from one end cannot go to the other end. What are the possibilities? But when you link with the advanced features and technology, let's say the RR community summarization work together, and the troubleshooting, you be make it more complicated. So in this case, you need to know what to check when all these components or all these features running together, how you're going to perform on the troubleshooting. So for the objective over here is, first we need to familiar with the common BGP tools and technology when a great number of the route exit on the network. Okay, when a great number of route exit on the network, how we are going to use the BGP tools to handling that great amount of the route, okay, or great amount of the peers. So that is what we can perform on the common BGP tools. That later we're going to mention on that. Understand the extended and the enhanced features of the BGP. Understand the concept of the internet design, and also understand and get the ideas how to configure on the BGP attribute and a troubleshooting. All right, so that is on the objective for this topic. For later, we have two lab to perform. Okay, two lab, but it's a simple lab on this. It'd be pretty straightforward. Okay, so later we're going to do in this on the case 1 and case 2. So for the contents over here, so for the technology regarding mesh BGP route, so what is be on the technology regarding mesh BGP route? So suddenly, let's say that you have a lot of BGP route come into your routers. How you can handling all this information? How can you be efficiently managing all the huge number of routing entry that come into your routers? So what type of the technology we can have to handling all this routing entry? So they have few method. Okay, from that, let's say suddenly they have a lot of route that you receiving or you're going to be sent to the peers. You can doing the route summarization. So before I send to you, since that I have 10,000 of route I need to be sending to you. So before I send to you, I said, well, it's very huge. In this case, I can try to just summarize them before I give it to you. You can summarize before they're sending to you. Okay, they have a different method or different scenario by handling the large number of the routing entry. So let's have a look. What are the technology they're going to be able to handling when you have large number of routing entry coming in or going out from your devices. Okay, so that is the tools. The following tools or technology are used to simplify the configuration, reduce the route entry, and improve the device performance on a large scale of network, or a network with the large number of route entry. So not only the route entry is very large, they also based on the large scale of the network. It means that within your AS, you could have more than 20 devices, 20 BGP routers. So how are you going to handle all these devices? Let's say you're going to do it one by one, you will waste a lot of resources. So that is where we can come out from the peer group. Okay, peer group. We also have a community attribute. This is more to the tagging, doing the tag. Route reflectors to reduce these two is to reduce the peers. Reduce the peers full match. Okay, so we do not require a full match connection when using a route reflectors and also a confederation. Okay, so that is what we need to go into later part, what you mean by route reflection and also a BGP confederation. Okay, that is a way of solve. Let's say you do not want to have a full match of IBGP. So that is all within your AS. This protocol is within ASs. Okay, within the AS. So the rest is between the peers or within your AS. It can be within or between. Okay, that is on the technology that can be handling to simplify your configuration. Either you have a performance or they have a large number of route entry. It can be dealt with. Okay, by using these 5 different BGP tools. And we look into one by one. First, we look into the route summarization. For the route summarization, by a BGP that perform the route summarization, they can provide 2 different types of summarization. Okay, 2 types for IPv4. Okay, 1 type for IPv6. Okay, so for IPv4, they have 2 types. One is called the classful summary. The other one is called classless summary. So the difference between these two, this one using we call also as a auto summary. This is a manual. One is auto summarization, the other one is on the manual summarization. Okay, so there are 2 different type of the summarization that can be done by the IPv4. So IPv4, they can support classful. But for IPv6, they have no classful addresses. Okay, they do not have any classful addresses into IPv6. That's why in this case, they only support on the manual summarization. They can only provide on the manual summarization for the IPv6. So these are the 2 different type of summarization into the BGP. So when BGP, when you have more than one network, you can be summarized into a single network. So let's say you have a 10.0.0.0.24. You have 10.0.1.0.24. Okay. So let's say you have these 4 address. You can easily summarize this 4 address into 10.0.0.0/22. So by who can doing this summarization? So in this situation, as long as this route, this BGP route is in your routing tables, then you can do the summarization. Anybody can do the summarization as long as that route appear into your device, appear into your BGP routing tables, and next you can perform the summarization. They do not need to be origin by who, then only can summarize by who. No. You can summarize anytime that you want as long as that route is inside your routing tables. Okay. And under summary route, they will not specific route are advertised to the peer to reduce the size of the routing tables of the peers. Yeah, so means that I will not give you the specific. So by sending this detail, I send 4. But when I send summarization, I only send 1. And this one is covered 4 of the address over here. So I'm going to reduce my routing tables of the peers. It's not my routing information. My route is still the same. But when I send to the peers, they reduce the peers routing tables. Yeah, instead of reduce mine, but reduce the peer routing tables. And also, if a specific route is flapping, BGP peers route calculation is not triggered. Because let's say I just send this summary address to you. I just send this. In this case, let's say I have link interface go down, or these 2 link, it doesn't matter. You will not trigger a withdraw. Because a withdraw is only trigger myself. Because I send to you, it's a summarization. So it will be not affected and not trigger the calculation by the peers. Only myself, it will do the calculation, but whichever I send to the peer is not affected. So that is also a benefiting for the route summarization. Whichever I summarize, I give you the summarization. So it's not affect what I have internally. Okay. And the route summarization is performed either automatically or manually. This is what I mentioned just now. V4 have manual summarization and automatic summarization. So this one is a classless. It means that you have to specify the subnet mask. And this one is a classful. So they do not have any information that you can, there's no subnet you can define. Everything inside, they will just go back to the default class A, class B, or class C. So it means that you only have a /8, 16, and 24. Okay. So far, right? Then for IPv6, is only support manual summarization. All right. So that is on the route summarization. So the next one we look into this is on the auto summarization. How the auto summarization it work into the BGP. Okay, it work into the BGP. Under automatic summarization, there's certain things you need to be followed. When you're using auto summarization, you have to make sure that this route has been imported to the BGP. Okay, import route. Import route, they'll do it auto summarization. Okay, but not the prefix by the network. It means that they only summarize whichever come from question mark. Whichever come from I, they will not perform summarization. Do you get what it means from here? They perform the classful summarization on the route imported to BGP. Okay, imported to BGP, then they perform the summarization. Okay. The BGP is only advertising a single summary route to the peers. Suppress the advertisement of the member specific route after route summarization is configured. Okay, means that on router 1, in my BGP tables earlier on, I should have this. I have 3. I have a 10, 0, 0, 0, 24, 10, 0, 1, 0, 24, 10, 0, 2, 0, 24. This is before the summarization. After summarization, they will have this. They will have 10, 0, 0, 0, /8. So this is what they will have after the summarization be done. When the summarization be done, by right, they will not show this. They will just show as a 10.0.0.0 because this is a classful address. Okay, so that is under router 1. When router 2 receive on the BGP tables, they only receive one route. Okay, that is before and this after for the router 1. Okay, before the summarization and also after the summarization. Okay, and what you get from R2, that is where you receive only one summary route. You do not receive the detail route by doing the automatic summarization. Okay, and this automatic summarization by default it disables. Okay, by default a disable on this protocol. Let's say I want to perform this, you're going to say that I want to have a inside a BGP. You tell that I want to have a summary automatic. You have to put this command into the BGP to provide the summarize automatically. So this one is pretty simple. They will just auto summary whichever come from the import route? Question mark. The question mark that you generated yourself, It's not anyway, okay? It's generated by you. You can perform the auto summarization. Is that all right? So this on the auto summary. For the rough summarization under the manual summarization. For the manual summarization, this one is more flexible, and this one we call as a classless. Classless. So they do not care about what are the classes. Class A, B, C, I don't care. But you have to define the subnet mask manually yourself. And for the manual summarization, they can summarize whichever learn from I, whichever learn from E, and whichever learn from question mark. Based on the origin, it can come from network statement, EGP, and also it come from import route statement. So you can import everything and they can summarize anything inside your routing tables. It's not only specific into the import route. So it can be a network statement as well. And the summarized route in the local BGP routing tables control the attribute of the summarized route and determine whether to advertise the specific route or not. So what it means from here is, let me over here, I will just add a page. I give you more ideas how the manual summarization will work. Manual summarization. Let me just insert another pages. Okay, so let's say right now from here, I have a router number 1. Router number 2. Router number 3. Okay, so that is on the router that I have. So I just using the same example that show from the book, okay, from the materials. So let's say over here I have a network of 10.0.0.0. From here I have 10.0.1.0 and also 10.0.2.0. Okay, so let's say I have this information from my environment here. So how are you going to handle this information? How are you going to handle this information? So in this case, I'm going to divide it to different AS. Okay, different AS. Okay, maybe I just extend one more. From here, extend another AS for router number 5. So at least that we can see what are the connection that we can perform. How the summarization is being done. So I have a AS10, AS20, 30, 40, and AS50. So this one is doing the manual summarization. Yeah, this is on the manual summarization. So in this case, the 10.0.0, 10.0.1.0, and 10.0.2.0 will be forwarded to everybody. So the direction that we send is done like this. Okay. So in this case, it means that in the router number 4, in the BGP tables, I should receive this. 10 0 0 0 0 24, 10 0 1 0 24, 10 0 2 0 24. So from here, you should see that where is your next hop. The next hop for this is from 24 112. This is 34 113, 34 113. This is all the next hop, and followed by the AS information. This one is come from 20 10 I. This one is come from 30 I, 30 I. Let's say this is the information. So on router 4, I can do the manual summarization any way that I want to, not like the auto summarization, only do it locally. Okay. So, and under AS4D right now, I perform the summarization. Actually, this information is not necessarily to be I. It can, one of them can be a question mark. It doesn't matter in my case, in this case. When I'm doing the summarization, I don't care either you are from I or from question mark. Okay. But it definitely can be specifying what you need to be followed from. All right. So in this case, I'm going to do the summarization on the router 4. So I'm going to do a summarization. I'm doing the manual summary. It's called as a aggregate. Okay. I aggregate the network to 10.0.0.0 and 255. I just make it as a prefix instead of subnet mask. I make it shortest. I make it as a 22. So when I just doing aggregate 10.0.0.0.22 on router 4, so they did not mention that which peer I do the summarization. When I doing this keyword, I will just add like this. 10.0.0.0.22. Who are the next hop? 0.0.0.0. Who is the origin? Myself, I. Okay, that is the information I will receive, and this information will be sending to router 5, is sending to router 2, you're sending to router 3, router 2, you send back to router 10. So when router 5 receive, router 5 inside the router 5 BGP tables, this is what I get. 10.0.0.0.22. Next hop, 45.114. And the AS information that I received is come from 40.I. Not only this, I still will receive this information 10.0.0.0.24. 10.0.1.0.24. 10.0.2.0.24. All come from the same next hop, but different information here. So by default, when you're just doing the aggregation 10.0.0.0, all the route that I summarize is still sending as a specific route. But when R5 want to go to 10.0.0.0.10.0.0.1, okay, 10.0.0.1, on R5, which one they will select? They will select the summary address. You still remember that on the route selection criteria, which one they select first? We select based on the manual summarization. It's not a detailed route, it's a manual summarization. I would prefer the summarization route first. So the first one is a preferred value. Second one is a local preference. And the third one is to prefer the summary route. So in this case, when this is summary, this detail, I go for the summary route and send to router 4. Okay, I prefer the summary route first before I go to the detail. That is on the selection criteria of the route selection. So when this R5 receive, it means that R2, R3, R1 will be receiving as well that this summary address. Okay, so in this case, R1, R2, R4, R3, R1 you will have another addresses going to the 10.0.0.0. R3 as well is have another address go to 10.0.0.0. Between R1 and R3, in this case, they might get back the same addresses that what they're advertising. It'd be very dangerous that if let's say this address will be removed or this address will be removed, the router 3 if we just think of or R4 know how to go. When R4 send to R2, R2 will send back to R4 because R2 will based on the summarization network. I based on this to go to the destination. So I might not able to go to the destination of 10.0.0 anymore because R2, when they check the criteria, oh, I have a summary address. I will prefer the summary address before I go for the detail. So in this case, R2 will go back to R4. R4 send back to R2, 2 to 4, 4 to 2. You keep on bouncing to each other already. So to prevent that, because right now when I'm generating the summarization, it's generated by myself. I'm the one who generating this information. Okay, so this information we call as a AS sequence. So they have to follow the sequence. Who are the person who generating this information is the sequence. So I'm the one who generated, so that is called as a AS sequence. They have another one is called, they have a AS sequence, and they have a AS set. So they have two information here to identify a different information. So what's the difference between AS set and AS sequence? AS sequence is just follow the sequence who creating this network, who creating this route. For AS set, they do not need to follow sequence. Okay, whichever they are come from, I will just put into the AS set. So let's say on the manual summarization that I perform, aggregate 10.0.0.0.22, I put AS set. Okay, I put AS set. So in this case, what will happen when I put the AS set on the aggregation? They're going to say that, all right, I will not generate it only by myself. When I change to AS set, this information will something look like this. They're going to have a curly bracket and to say that they are come from 10, 30, curly bracket, I. Because of who come in first, 10 come first or 30 come first, I can't specify. Using AS sequence, I can't specify. AS sequence must be in sequence. You come from 1, 2, 3. But right now, it comes from two directions. I can't specify the sequence. In this case, I have to use this as a AS set. Okay. When you have AS set defined, when R4 sent to R3, this is not accept. When R4 sent to R2, this is not accept. And this is accept, sorry. And this is not accept because I have 10 inside my information. By right, they should have also this is not accept. Yeah, by right, it should be something like this. Yeah, 10, 20, 30. They're coming from this AS before. So in this case, when I send back the summary address to you, you will not accepting. You will not accept, you will not accept. Okay. So far okay or not? In this case, this summary address will be not sending to the peers. They were just sending a detailed information. Okay, the detailed route, but not the summary route. And this summary route is only sent to router 5. And router 5 receive will be something similar that I showed over here, by using AS set, this is what they are showing. They will have a 40 followed by a curly bracket, 10, 20, 30, I, something like this. This is what they will get as the information by the router 5. They come from this AS before. Okay or not? But sometimes they show you a curly bracket, or sometimes they just show you a round bracket. That's what they will show under the manual summarization. Okay, so they can be defined the AS set. Okay, then also you can add on behind. You said that detail suppress. Okay, you can do it detail suppress. Detail suppress over here, it means that when I have detail suppress, this information will be changed. If from X straight to S, suppress, 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 and from here you never receive anymore. So for router 5 in the AS550, they only receive a summary route. Let's say you deploy the detail suppress. Okay. So far, okay. So that is a meanings of the manual summarization. They can based on the AS set, detail suppress. Inside the aggregation, we also have this. We call it as a origin policy. Okay, and also we have an attribute policy, and suppress policy. So we have a 3 different policy can be assigned into the aggregation. Under the origin policy, is just to tell that based on what origin you need to perform as an aggregation. So just like a condition. Based on whichever who meet this condition, then I do the summarization. So I said that I do not want to summarize everything. I need to specify, anything come from these addresses, with these addresses, I perform aggregation. And this is what you call as a origin policy. Okay, based on the condition of your aggregation. What you need to perform aggregation is based on your origin policy. Okay. Attribute policy is, let's say you want to change the attribute after the aggregation being done. So after aggregation, I said that I want to do a tag. I want to tag the community numbers into this summary address. Then I can use the attribute policy behind the aggregation. Okay, this one is changing the attribute of the aggregation route. And the last one as a suppress policy. It means that suppress policy and the detail suppress is similar. Detail suppress, I suppress everything. But suppress policy, you can specifically to tell that which address you want to suppress, which address you will just send out as normal. So this it can be specifying by using the suppress policy. All right. So they have 3 policy: AS set, detail suppress. So inside the aggregation, you can have another 5 more features inside the aggregation. The first one is AS set, detail suppress, origin policy, attribute policy, and the suppress policy. These are the 5 information we can be used inside the manual summarization. So you can see that it be more flexible. There is more they're more flexible for us to define the summary route using the manual summarization than the auto summarization. Auto, just straightforward, it's just doing as a classful addresses. Okay, that is on the auto summarization. For manual, it give you more flexibilities. Is that okay? Up to this point, if this with my explanation, can you understand on that? Okay, so let's look back into this on the route summarization under the manual summarization. So you can see that from here, I have 10.00, 10.0.10. It comes from AS100, it comes from AS100 and 200, it comes from 300. confederation. So after a route with the attribute received, it cannot be advertised out of the local AS or the local sub AS. It is very similar to this, but this one is under the sub AS. Okay, the sub AS. Later we also will go for this confederation, and later we look into this what we can define under the sub confederation. Okay, this is on the communities. So in your lab exam, whichever I mentioned on the advanced advanced BGP, you need to be aware because you be tested into your lab. Okay, the function that I mentioned is already be tested, like the peer group, summarization, communities, and the next one is a route reflectors. So all these things they will ask into your lab exam on this advanced function. So first we need to know why we need to use a route reflectors. Okay, why we need to use a route reflectors. Okay, so from here I'm going to show another diagram. I'm going to draw another diagram to just explain to why we need to use the route reflectors. All right. Let me just add another pages from here. Okay. So first, route reflectors. But before route reflectors, why we need to use route reflectors? So you still remember that that we mentioned when you are the transit AS, your device must be full match. Am I right? So let's say I have this situation here. A, B, C, D, E, F. This is a physical connection in between the devices. So AS10, AS20, and AS30. So over here, I'm going to form all the different peering. This is my eBGP. This is my eBGP. Okay. First, I will tell you that why we need to have full mesh first. They have iBGP. Okay. This is the environment that I have right now. So let's say right now, I have an advertisement need to be sent from router A. Yeah, need to be sent. So who can receive? Can router F get this 10.0.0.0? So based on the advertisement principle, when this is optimal, when received from the eBGP, I can send to the next iBGP, send to the next iBGP. When I receive from the iBGP, I cannot send anymore. When I receive from the iBGP, I cannot send to the next iBGP. So it means that that's all. Let's say you are doing this like this method of the iBGP peers. So it means that router F you never receive. You never receive the information. So how are you going to make it to allow router F can learn about the 10.0.0.0? In this case, in the transit AS20, we need to perform the full match. Okay, this is the solution that we mentioned under HCIP to provide the full match. So it means that from here, I'm going to build a logical peers of iBGP. So in this case, the traffic will be forwarding in this direction to router E. When router E receive from eBGP, iBGP, I can send only to the eBGP. I cannot send to C, I cannot send to D. So to make sure that there are the loop preventions. Okay, so F can learn the information. That's why when you have transit areas, you always need to have a full match. Okay, full match. But when using a full match, you found that they have an issue here. So 4 routers for full match, how many peer connection required. 4 routers, full match. How many iBGP peers they've required? So let's calculate. So we have 1, 2, 3, 4, 5, and 6. So in total, it will be 6 iBGP peers. So how about 5 routers? Full mesh. How many peers? How many iBGP peers is required? Okay. How are you going to calculate this? Do you need to draw it out and calculate one by one? So actually from this, they have a formula to define in total how many peers were required. The formula will be n times n minus 1 in the bracket and divided by 2. Based on the example just now, 4 times 3, 4 routers divided by 2, you get 6. When 5 times 4 divided by 2, you get 5 times 4 will be 20. 20 times 2 divided by 2, you have 10. Let's say about 10 routers times 9, you get 45, and so on. So you keep on increasing. When the more the router that you have, the more the peer that you're going to build. Full mesh is good when your network environment is not too huge. But let's say your network environment is very huge, then it's not preferred, it's not recommended using the full mesh. You can use the route reflectors. Okay, using route reflectors to solve the problem. Is that okay? They have 2 solutions. Can be route reflectors or can be a confed. Okay, confederation. And later they will cover on this. Okay, this is why the full mesh is required. Okay? And what are the disadvantages of the full mesh? Because they need to build a lot of the connection when you are doing the full mesh. So to reduce this, that is a solution by defining the route reflectors. Okay, by defining the route reflectors as a RR. So route learned from iBGP peers can be advertised to specific iBGP peers, and this prevent iBGP peer relationship from being fully matched and reduce the number of iBGP sessions to be established. This is what just now I emphasize is because route reflectors, they will just reflecting the information to the peers, and router function as a RR and client. So you just have to specify routers. Okay, have to specify the routers. One of the routers become RR. The rest is a client. In this case, only the client I need to form the connections, the iBGP connection. So in this case, how many iBGP connections are required? 1, 2, 3. Only 3. From 6 right now, I only need to have 3 iBGP peers. It's a lot reduced compared to a full match. Okay. On this reflection, whichever received from RR, I just reflect this information to my client. So under the reflection rules, like the next page, I'm going to mention how this reflection is being done, and also what are the relationship they have the RR and the client. We also have a RR, we have a client, we also have a non-client. Okay, so we have 3 different roles over here. Later, I'm going to explain to you what are the differences between these 3 different. Okay, so RR and client. Client do not need to know they are the client. Okay, RR is the one who know who is my client. So when I receive an update, who can I send? I place on the list who is my client and I send to my client. Okay, that is the a way of define the route reflectors. The benefiting by using route reflectors. The client do not know themselves as a client. They need, they just have to send the form the peers with the RR. I also do not need to know who is the RR. Okay, I just sharing the information going to the RR. Okay, for this route reflectors basic environment. So for non-client, it means that they just form a normal IBGP. Means that RR did not define yourself as a RR. It's just a form of normal IBGP. This is special IBGP because you are the client. Okay, that is what they were providing. Okay, so inside the route reflectors, they have this information. Also have a casters. Caster is a caster IDs. The caster ID of these route reflectors. They can build multiple casters. Caster 1, caster 2. Okay, they can back up to each other by using the caster. The caster, and also we have a caster list. From one caster to another casters, they need to pass through the list. Just like the AS path we're talking about on the BGP AS, when they pass through the AS path, they need to keep this information, keep the AS information into the AS path. Same thing to this. They'll put the caster ID into the caster list. Every time they go out from the caster and go to another casters, they're going to add their caster ID into the caster list and forward to the next casters. Okay, this is a loop prevention within your IBGP and within your AS. Okay, and we also have another one is called originator ID. This is to tell that who origin this route. Route reflectors, it just help you to reflect the route. But I need to put this originator ID to tell that this route is who are the origin, and I'm the one who just reflect. You send to me, I said you are the origin of this route, and I forward to reflect this route to the rest. Okay, this is on the originated IDs. Okay, they need to add this ID into the route update that I received from the client. When client give it to me, I need to add you are the originator IDs. It's not me. You are the one. I will add your router ID into the route update and send to everybody. Okay, to say that this update is come from this originator IDs, come from the client. Okay, that is what we have inside the route reflectors. Okay, we have a RR, we have a client, we have a non-client, we have a caster ID, we have caster list, we have also have a originator IDs. So these are the information that we have inside a route reflectors. Is it okay up to this point? All right, so before I continue, let me just capture the attendance for this morning. Okay, hold on. Okay, so that will be on the next, after a route reflector I mentioned, I need to go for the next one. Is on the reflection rules. Under these reflection rules, I'm going to tell you that how they're reflecting the information. Instead of using this slide, I'm going to use my own slide, own diagram. for this. It'll be easier for you to understand. Okay, make it a bit clearer. Okay. So from here I have two AS10, AS20. So this is my customers. Router B is my RR. Router C is my client. Router D as my client. Router E and F as my non-client. Because it's not inside the cluster, it calls as a non-client. Between A and B is running eBGP. Between the rest is running iBGP. All right. So right now I'm going to have three different colors. Okay. So I have an eBGP route, client route, and non-client route. Okay. How the RR behave when they receive the route from eBGP, the route from client, the route from non-client, how they behave. So first on the eBGP route, okay, when this route advertising to router B, to the RR, what RR you perform? When router B as the RR receive a eBGP route, I just reflect to everybody's. Okay, I reflect, 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 reflect. So this one is straightforward. When you will receive a route from eBGP. Okay, this one okay. Next, when clients advertising the route to route reflectors, reflectors reflect to the client, reflect to the non-client, and also reflect back to the eBGP, advertise to eBGP. Okay, that is what they're going to do. So it'll be the same. When RR received from client, I will send to everybody as well. And the last one, let's say the non-client send a route to RR. RR will only send to client, sorry, client, and also eBGP. That's all. So whichever non-client receive from the route received from non-client, I only can send to the client and the eBGP, but I will not send to the non-client. I will not send out from here because this one is go back to the principle that when I receive the IBGP route, I will not forward to the next IBGP. Okay, I will just keep for myself and send to eBGP and send for my client. This is a extra rules that you need to know because based on the diagram in this page, they have only one non-client. So in this case, you might confuse to say that, oh, when I receive from Ethernet, from eBGP, I can send to everybody. When I receive from the client, I can send to everybody. I can receive from the non-client, I can send to everybody. Actually, it's not correct. When you receive from the non-client, I can only send to client and eBGP only. I will not send to the next non-client. Because within the non-client, you should have a full mesh peering here. So you should have a IBGP peering yourself for you to forward this information to the non-client. Okay? So do you grab the point that what I want to bring out from here is on the route reflection, the refract rules, how they refract the information, how the route are handling the reflected rules, okay? Reflected route. So whichever come from eBGP, yes, I can send to everybody's. But whichever come from client, yes, I can send to everybody's. But whichever come from the non-client, I only send to the client and the eBGP. That is where and how they reflect between the client, non-client, and also the eBGP route. So far, is that okay? Based on this explanation, can get the ideas? So okay, no more question on this. Simple, straightforward. All right, so the next one is on the route reflectors. Okay, route reflectors. Route reflectors on the anti-loop mechanism. How the route reflectors to prevent anti-loop. How to make sure that there are no loop inside the route reflectors. So within the full mesh, they have principles to say that when I receive the IBGP route, I will not send to the next IBGP route. That will be very simple, very clear already. Okay, for the anti-loop mechanism under the route reflectors, that what we have here is we have a originated ID, we have a cluster list attribute. These are the two methods for us to doing the loop prevention within the route reflectors. Okay, within the route reflectors, within the clusters or between the clusters. Originator IDs is the attribute is to optional non-transitive, is to use to prevent loop within your clusters. It's generated by an RR and carry the router ID of the device that advertising the route into the local AS. So in what type of situation you get back the information? Okay, it'll be something like this. Let's say you have this. You have a RR1. You have RR2. You have a client. You have a client. Okay. So in this case, when the update is be sent, RR1 sent to RR2. When I receive from the non-client, I will send back to the client. When client receive the information, let's say without any identity, I will accept. Let's say I do not know how to go anymore. But in this case, when I receive back information, I found that this is the same what I originate. I'm the one who originate this route. In this case, I will not accept that what you sent to me. Okay, there is some method how that can be defined when you be in the same clusters. Okay, when these two routers is in the same cluster, that you're going to be prevented within the clusters. Okay, they're going to generate the originator ID as your router IDs when you receive a route from the client. Okay, this is how to prevent the loop within your clusters. And for the cluster list attribute, when you have a clusters, and clusters, these clusters are interconnected. So in this case, whichever that you send, you might come back to you from here. In this case, when I look into my cluster IDs, I can see that, oh, this is what I sent, so I will not accept. So similar to the AS path that I mentioned, doing the loop prevention between the clusters. Okay. The attribute is optional non-transitive as well. It's used to prevent loop between the clusters. It's generated by the RR and record the cluster through which a reflected route passed through. So every single route reflectors you're passing through, I will add my cluster ID inside the route update to say that this route passing through how many cluster before. So in this case, based on this information, I know that, oh, how many clusters that pass through. Let's say I have two-way. This is using two cluster. This is using one cluster. So I follow the one cluster to reach my destination. Oh, this can be done as well. Also, it's a method to define the best path, and also it's a method of the loop prevention. So it's the same as the AS path list. So the lesser the AS path, then it'll be the best path for me to select the way of the route. Okay. So this is on the ND loop mechanism under the route reflectors. So far, is it all right? Yes. Any questions? Sino? Okay. So let me continue from there. After mention about the ND loop mechanism, the next we look into is on the backup RR. Okay, backup RR. Under the backup RR, what is inside the backup RR? So RR in the same cluster share the cluster IDs. So let's say you are under the two clusters, then it's different as the cluster IDs. Let's say under the same cluster ID, you belong to the same clusters. Okay. Cluster lists ensure that no routing loop occur between RR into the same AS. Okay. So on this example over here means that I have a RR1 and RR2 is just using a common IBGP. This is not a client of this. This is not a client of this. They're just forming the common IBGP peering. Okay. But whichever I receive from the client, I reflect to you. I reflect. When I receive from the non-client, I reflect as well. So I will keep on reflecting the information when I going to provide as a backup RR. Okay, that is what they can provide. Okay, the backup RR over here, they did not mention that which is active, which is standby. For RR, they running at the same times. Okay, they did not mention which is an active RR or which is a backup RR. We can't differentiate that. So this is just all depend on the client, how they define which RR I used to receive the information. Which one is my considered as a best route from the RR. So I depend and compare their router IDs. Okay, between RR1, RR2, which router ID will be better. Okay, that is where I can define. Okay, to select when you have backup RR. Backup RR actually concurrent, both are running. Just that when one RR go down, another RR will just take all the full resources, okay, the full responsibilities of all the route they're going to be forwarded. So the better way, always we need to have one backup RR. You just not only just one RR. You imagine when your RR go down, your client is only have one peer to your RR only. When your single RR go down, means that all your client will be lost connection. So that's why we better to have more than one RR. At least you have two RR to provide the backup. Okay. In case of a RR fail, you still have another route RR to backup. Okay. That is on the route refactors backup RR. Is okay. And the next one is on the route refactors. This is under the flat network. Under the flat network. So most of the time in our environment, in the enterprise environment or campus environment, we're using this method as a flat environment. Okay. SAS may consist of multiple cluster and RR establish IBGP peer relationship with another one. So over here, this is a common IBGP. Yeah, this is the same as the same. So what it means over here is to make sure that they have no loop in between the clusters. They make sure that whichever that I send from the non client, I send to client, but I will not send to the non-client. Whichever I send to the non-client, I will not send to the non-client. I can send to my client, They have a loop prevention over here already. Okay, based on the mechanism on the refraction rules, whichever is non-client, when I receive from the non-client, I will not send to the next non-client. This is how they apply into the flat environment. So you have a RR1, RR2, RR3 under a different cluster. Cluster 1, 2, and cluster 3. Okay. So from the client can go to another client through the RR, passing through the RR. Okay. And all the RR, they over here need to be full match. Okay. Full match between the RR device. Is that right? Okay. Next is on the hierarchy RR. So this one will give you a hierarchy of the layers. So I have a top RR, layer 2, layer 3. Okay, I have multiple layers, multiple hierarchy. So when you're doing the hierarchy method of the RR, so you have a RR1, below you have a client of this RR1, and this routers also as a RR for the next client. So means that the intermediate device, they're going to have two roles. I'm the client of my upstream, I'm the RR of the downstream. So they divide by layers. Cluster have three clusters here. Cluster 1, 2, 3. RR, client of RR. This client of this RR. So in this case, they can be easily defined in under the hierarchy. But seldom I will see this method of a hierarchy RR. Most of common view method of the RR we using still the same level of RR. Everything as under the same levels. Okay, flat network. And the next one, and this is where the confederation come into. Confederations. Confederation means that you're going to divide your AS into the several sub AS. Cut it to the smaller AS from your confederation AS. Just like this. From all the 6 routers is belong to the AS100. From the AS100, I'm going to cut to a small piece, 3, 2, 1. So when I cut it to the small piece, they're going to form a special eBGP between the sub AS. Okay, eBGP. Over here is IBGP. So from this, you need to be full match. You still need to apply the full match within the 3 devices. Okay. So let's say I will go back the diagram I draw just now. Just now I showed route reflectors and the full match. Let me just come back to this. Okay, come back to this. So when let's say in this method using a full mesh, I need to have a 6 connection. Using route reflector, need to have 3 connection. Let's say right now I'm modifying. Let me just remove. I will show you the configuration in this environment here. So there's no RR anymore. When this is configuration, what we should have aware on this. Okay, so let's say we're going to do the configuration. You can decide that from here, I'm going to classify into the 2 sub AS. I will say that between BC and between DE. So I define this as a AS 6500 001. 6500 002. So I just try to use another numbers to representing this under my sub AS. So when I have a sub AS, it be defined. So in this case, my peering, it be different already. This one is still fall back to the IBGP. Okay, this one is still fall back to the IBGP, and this one is fall back to the eBGP. Okay, so you can be using one eBGP or you can using 2 eBGP. All right. In this case, when the update route up information come from the eBGP, based on the advertisement rules, I can send to the next IBGP. I can send to the next eBGP. From this, I can send to the next IBGP because I learned from eBGP. Learn from IBGP, I can only send to the eBGP. Okay, and this I can send to the eBGP. So this one, you're going to, without any full mesh, without any route reflectors defined, you don't need to know who is a client. But by using this configuration, you need to change your topology. You need to modify, you need to reconfigure your environment to support configuration. That is the only things we need to do. By using this, between the sub AS, they form the special eBGP. Using eBGP to form using the sub AS numbers. Means that I'm going to have peer router D sub AS put to the AS 65002 and so on. Okay, the numbers of means that you need to form the peer again. Okay, form the peer again between the sub AS. So when you configure the configuration, you can consider you redo everything. You reconfigure everything one more time. So this one it takes a lot of time. So normally when you have a live network running already, you will not using configuration. You will not shift to configuration. Okay. Only when you have a new network, you can consider to specifying the configuration. Otherwise, it's not. Otherwise, I was just using the route reflectors. It's good enough already. Is that okay? on the confederation example that I showed from here. Let's say, okay, I will go back to the slide. We stop this now. Confederations. All right. So that's what I mentioned over here. There need to be full mesh. Anything more than 3 routers still need to be a full mesh connection between the peers. The rest is just from a special eBGP connection. All right. So after the confederation is being configured, in this case, between the eBGP, between the IBGP, you can go more in depth of the, like, define the attribute, local preference, MED, next hop. It can be done inside the confederation here. But before you add, you need to clean up everything first. So it means that you need to act as like a new network, okay? A new network. Is that okay for the BGP confederation? So the next one is on how the BGP confederation to prevent looping. Okay, prevent loop. So the prevent looping will be very similar, just like AS path. Because they have a different sub AS. When sub AS to sub AS, we need to make sure that they need to define how to perform the numbers of the AS confed sequence and AS confed set. Okay? Sequence and set. So when the AS sequence, it means that when they're coming in or going out, they are using the sequence information here. Okay, but internally inside the AS200, they're going to have using the AS confed set to tell that where they come from. They come from the sub AS 65001, 65002, 65003, and so on. So they're going to use the set inside the confederation. When they're going out, it's just using the AS confed sequence. Okay. And just now also I mentioned about on the community, the no export sub confed. Remember? That is what it means that here's whichever that you receive, I send to you. I will send this communities. No export sub confed. It means that when I send to you, you cannot send out of your sub AS. You cannot send to R2, but you can send to R4. This is what it means by the no export sub confederation. Is okay? So that is how they're doing the loop prevention on the using the AS confed list. Okay, the AS confed list, make sure that they are passing through which device before. So far okay for this loop prevention from the BGP confederation. Let's say nothing. Then we can look into this, the comparison between the RR and the confederation. What are the differences between these two? Okay, between the RR and also confed. So you can see that on RR, you have a pretty simple of configuration of the RR. The exit network topology does not need to be modified. More compatibilities is very good. Okay, it'll be easier. So, and also the configuration is simple. A client does not know themselves as a client. Full mesh connection must be established between the cluster, the RR themselves, and is widely used on the large scale of network. So it can be very simplified, easily simplified to tell that how it can be done by using this method. Okay, so this is on the route reflectors itself. But when you look into the confederation, the logical topology need to be modified. When you're specifying this, your logical need to be modified. It means that you need to rechange your topology, because the topology is no longer just like a normal information array. you need to redo everything. You need to set who is the config, which one is config sub AS, which one is which config sub AS. So you need to specify where is my sub AS allocated to. So that we have more information need to be defined under the configuration. Okay, and all devices must be reconfigured and support the configuration function. So you need to make sure that every single protocol that you use must supporting the reconfigure on the configuration. They must support configuration before they can move on. It's not like RR. RR just have to do the changes under the RR. Client, anything, it just remain. Just a normal peer for them. For the configuration, everything need to be changed. The sub AS in the configuration establish special eBGP connection and do not need to be fully matched. But when you have more than 3 devices within your sub AS, something like this, you still need to have performed the full match. You still need to fall back into the full match. Okay? And for last one, for this, very few applications are using the BGP configuration, but most of them are still using the route reflectors. Okay, the comparison between RR and configuration, is it okay? Any question you want to ask from here? So it's all good, huh? Okay. So the next one we look into this is on the extended BGP features. Okay, extended BGP features. Under extended BGP features, what information that we have from here? So we need to know what inside here. We have like how you secure the securities, how we're going to define the TTL numbers and so on. So this is where we're going through. The first one on the extended BGP features is called securities. Yeah, securities. So under first one, the BGP security we can define the authentication between the peers. Between the peer, we can set on the MD5 authentication. So when we perform establishment on the TCP connection, I can ask for, hey, I want to check on the MD5 authentication before the TCP connection can be established. So I'm doing on the MD5 authentication. Yeah, that is one thing we can define. MD5 on the peers. Peers authentication. Okay. GTSM, Generalized TTL Security Mechanism. It's called a GTSM. Just GTSM, it will check whether a TTL value in the IP message is within the defined range. So which help to protect the services at the IP layers to enhance the security system. So this is defined on the TTL. So every time that you form with me, I need to make sure that the TTL is matched. It's only one hop away. Let's say your TTL is more than one hop. It means that you might be not coming from the next hop, you're coming from next hop. So in this case, we need to be aware. So you need to know that from this peer sent to you is how many hop away. So you need to be specified from here. Okay, you can specify under TTL security to make sure that every time the update that I receive from the peers is always only one hop. So you can also set multiple hop away. Let's say you know that it's far away from you, always need to be using 2 to 3 hop before then up to you. Then you can set what the hop count, the maximum hop count in this case. Okay, so this is what we can define under the generalized TTL security mechanism, the GTSM. Okay, and the limiting the number of the route that can be received. So you can set the limitation or how many routes are you going to receive to prevent the exhaustion attack that keep on sending you until up to the maximum. let's say you do not set the limited. You can limit that I only can accept 10,000. Anything more than that, I will not accept. You can set the limit of the route you're receiving. And you can protecting the AS path attribute length. Okay, the length of the AS path. So means I can say that I only allow anything within the 100 path. That is pretty lot. Maybe it's just a 10 hop or 15 hop. That is where it can set up to the length of the AS path attribute. Okay. So far, okay. That is on the AS path attribute length. We can set into the maximum up to 10 hop away. Anything more than 10 hop, I will not consider that is my best path. Okay, you can set the AS path attribute. And the next one is on the extended BGP features as called route dampening. Okay, route dampening. Route dampening is used to solve the problem of unstable route. So when your route is keep on flap, up, down, up, down, up, and down. So every single flap you happen, I need to withdraw the route from the peers. I need to send the update to the peers. To solving this, what are the another solution we can provide? Remember just now we mentioned on the summarization. Summarization can be avoid these things. When you have any route flapping, you not affected me because of I will just send you the summary route, but you affected yourself. You need to recalculate yourself. To prevent this, you can enable the route dampening. Route dampening is just like a penalty value you'll be measuring for the stability of the route. So I give you a value to tell that how stable of your route. Let's say your value is very high. In this case, that means that you are not stable at all. That is called a penalty value. So from here, every time you go down and come back, you flap, I will going to increase the penalty value. When you're up to suppress value, all right, I'm going to stop you. I will not handling this information for you. When you keep on go up to the maximum suppress value, I totally stop your information. Okay, so they have a maximum suppress value on top. Okay, they will say you keep on flap, I will just forget about you. I don't care about you. I will not deal with you at all. Okay, until you come back to the reuse value, and before I handling back your information. Okay, if the penalty value reach to the specific maximum suppress value it defined, and the penalty value does not increase anymore, that is up to the top already. You can set up to the top, okay, for them to coming back. So as long as when they're above this, they will not handling. But when up to the maximum, they will not go any more further. This is maximum already. Then they're coming down again. Okay. So when coming down all the way back to the reuse unit before they can reuse. So you can set the half-life. The half-life. The half of the intervals that you set, they're going to be reduce your penalty value. After the half-life, reduce your penalty value until your penalty value drop up to the reuse value. Okay, means that within this half-life, you do not flap anymore. Okay, you not flap. Okay, I will going to fall back, go down and go down until the reuse value before you can perform and use the route or advertising the route. That is what we call as a route dampening. Okay, this route dampening is more applied into the eBGP route. Okay, eBGP route. iBGP route cannot be dampened because local AS route are configured as a iBGP route. Okay, this is only meant for the route from the eBGP. Okay, from eBGP. And the half-life that you can set manually yourself. How long for the half-life? So you're going to define the value manually yourself. Is that all right? Okay. So for the next one, we look into this is on the enhanced BGP features. So this is on the enhanced function. It's not attribute, it's just a features to can enhance your BGP status. So the first one we look into this is on the BGP ORF. ORF is stand for outbound route filtering. Okay, outbound route filtering. So what it mean by this outbound route filtering over here is the outbound route filtering is just to tell you that I'm going to filter on my outbound before I send to you. Okay, so just like some of the devices that on the enterprise, they have a not strong, not very strong devices. They cannot doing the filtering themselves. I cannot say that I give you 500,000 of route. You do your calculation yourself. You do the filtering yourself. It's difficult for you to do that. So in this case, I said that, hey, upstream service providers, before you send me this route, can you do the filtering first before you give it to me? And how you do the filtering based on what I instruct you to do. I will send you the how I'm going to filter. I give it to you. You use your CPU process to filter before you send to me. Okay, so it means that you're going to ask your upstream to do what you want and send back to you. So you instruct your upstream to tell that, hey, this is a policy I want to perform, but I want you to do it for me before you send to me. So in this case, it can reduce the CPU usage on your local devices. It could be because of your device is not that powerful to handling all the processes. So you're going to alert your upstream to do that for you. So this is the way of the ORF. Okay, you instruct your upstream to give you the ideas, to give you the filtering information only, not give you all the route information. So that's why under this ORF, they can provide the ORF based on the prefix or VPN ORF. Okay, VPN instant or the prefix-based VRF. Okay, these are the two things it include inside the ORF that can provide. So when using ORF, we have this route refresh. Okay, route refresh will be sent because it's changing the policy. I send the policy to you for you to perform the filter before you send to me. That is called the ORF, outbound route filtering. I will send to the upstream, hey, this is what I need to define. Can you please send me the correct way? After you advertise, you send to me. After you filter, you send to me. Okay? So far, all right? Any other questions? On this ORF? Okay. So the next one is on the active route advertise. Okay, active route advertise. Under the active route advertise, what you have over here is the BGP route can be advertised to appear only after the BGP route is successfully installed into the IPv4 or IPv6 routing tables. Okay, so you will find very familiar. This will be very similar to the BGP synchronization, but this is not synchronization. This is not synchronization. This is not synchronization between your BGP and IGP. No, this is only between your BGP to BGP. Okay, so it means that I'm going to make sure that R1, when you have active route advertise, it means that, let's say this is my active route, 10110. This is my active route, 0000. I have to make sure that this route inside my IPv4 routing tables is also using 10.1.1.0.24 are using BGP to go out. Let's say in my routing tables, you tell me that, oh, your best go to 10.1.1.0 is using OSPF. Oh, then I will not send. I will not send this. Okay, they need to make sure that it's an active route advertised inside my routers before I can send this information. Okay, it's an active route advertised. All right. So only is active before I can send. When it's not active, I will not send. So let's say it's OSPF, then in this case, this network I will not send to router 2. But when the routing table is show me that, oh, this is learned from BGP, it's installed as the BGP. Okay, then I can send this information out to the peers. This is what they're sent. This is what they're going to perform. When you have a better route using IGP, then this route I will not advertise into the peers. They were going to check this in this case. It's called active route advertise. So by default, router can be advertised to the peer only when they are preferred BGP route. After the active route advertise feature is configured, a device only advertise the preferred BGP route that are active inside the route management plan, mean your routing tables. Last time, when this is not enabled, even though this is learned from OSPF, I still can send when you do not active route advertise. But after this, you need to, when this happen, when you enable the active route advertise, they must make sure that it's run between on the BGP protocols. Is that okay? For enhanced BGP function, active route advertise. So grab the ideas what it means by this active route advertise already. Okay. And the next one is on the 4-byte AS numbers. For this 4-byte AS number that we have, last time they only have 2 byte. And now they increase to the 4 byte. By using a 4 byte, we need to using the extension attribute. In total over here, they're going to have this attribute added in. We call it as a AS path, AS4 path, and AS4 aggregators, as well as the AS trans attribute. Okay, these are the 3 different attributes they added in to use to communicate between the ASs. Okay, between the ASs. So we have right there over here in this example here, we have AS 10.1, AS 20.1, AS 30, AS 40.1. So in the between over here, we have a AS 30. It's a AS 2 byte. I have AS 4 byte, AS 4 byte, AS 4 byte, but in the middle, I have AS 2 byte. So how they're going to be able to understand, because AS 2 byte might not understand the AS 4 byte. So in this case, when I forward the information from the AS 10.1, when I send, I have a R1. When I send this, I have a 10.1. Okay, I have a 10.1 here. When I have 10.1, it means that there is a 4 byte of AS path. Let's send to R2. R2 also have this 4 byte. But this information, when it's sent to the O section, when they're not supporting the AS4 byte, what I'm going to do, I will send the AS path with the AS transition 23456, 23456. Okay, using the AS tran. This value has been reserved for the AS transit 23456 as a transit. So in this case, R3 receive it. I know that, oh, they're passing through 2 AS paths. But this 2 AS path is 23456. It's not important to me because I do not understand 4 byte. I do not need to know what is your 4 byte information. What I need to know is what is your 2 byte information. So in this case, when I send to the 40.1, I will have a 30, 23456, 23456, and also I have a AS4 path. So it means that they need to refer into this 2-way to know that where they are passing through before. They have a 2 byte and 4 path. Okay, 2 path or 4 path, 2 byte or 4 byte. Okay, that is where they can be handling and where they're going to be identify that where you're from, who you are, where you come from, and so on. Okay, that is what we need to be emphasized when we are going through on the 4 byte of AS numbers. Is that all right? In this point, up to this. Any more questions? Okay. So, and the last one over here is on the policy-based next hop recursive or recursion. The policy-based next hop recursions, a route policy is used to limit the recursive route. If the recursive route failed to match again the route policy, route recursion failed. So what it means from here, you can see that based on this example, it said that right now R1 go to 10.0.0.0.0. Where is my best way? My best way is using the router 2 because this is a lesser router ID compared to the 3333. 2222 have a smaller router ID compared to 3333. So this is my best path. Go to 10.0.0.0. Okay. So when this go down, router 1 will check, hey, router 1 will found that, hey, I still have another way go to 2222. This is a way go to 2222. But you never able to reach because it's a different addresses. This is a 2.2.2.100 is /24. But when you're having this, you get this as a 2.2.0.24. So in this case, we can set the recursive policy to say that, hey, when your neighbor, your next hop will go down, you will just go down. You do not need to check how you go to this destination anymore. You just go down and you fall back into the new next hop. Go to 3333 instead. Don't just figure out how you're going to reach to the 2.2.2.2. Okay, so in this case, you can just set that I'm going to set the recursion policy just to the next hop of 2222. Only depend on the 2222/32. When this go down, I will not check the 2.2.2.0. I will not check on that. I will just fall back and fill over to the 3.3.3.3 as my next hop and go to the destination. Okay, that is called the policy-based next hop recursion. I will just always fix what is my next hop I can go up to. This way the method I can perform. Is that okay? Based on this explanation? Okay, and next is on the internet design fundamentals. So how do we need the BGP? Why we need to a BGP? From here, this is on the example here. We have three methods of the enterprise environment connect to the internet, like single home, multi-home single AS, dual home, multi AS. Okay, they're using one ISP, using dual home, single ISP, dual home, multi ASP. So in the first method, in this case, you do not need to configure BGP. What you need, you just need to have a default route. Okay, into default route, it'll be good enough already. Okay, and the multi-home single AS redundancy is implement between the link and the devices. So in this situation, your private AS number are used on your network. It's possible. Okay, if two link are working and the active standby, BGP is not required. Let's say they're running on the active backup, then you might need to active. You might need to running on the BGP protocols. But in this method, let's say you're using multi AS and multi home, you might need to perform the BGP protocol with the public. This is a public. This is a public, and yourself need to can be a private information. But this can be public, private to private. Even is private to the public and this is why and where we need to come into the BGP to define that in which situation we require to use the BGP environment. So let's say that when the method one on these two, when they have two routers advertising the default route that cause us a type E1 into the local AS. So in this case, they might have an issue of the method inside your V4 network or V6 network. So normally we're going to use a BGP environment, depending on how big of an environment behind over here. Because over here, I should define a default route. Okay, I should define a default route. Between these two, I should learn the detail route, or also can use a default route. But when using a dual home normally you get the route between the ISP1 to the ISP to your internet network. So you should using the routing information. Okay, routing BGP. Same thing is using BGP over here. You pointing a default route, go to your network. When using a one routers, you're just using a default route, you're good enough already. Okay. Which type of network need the BGP? So this is on some consideration why we need a BGP. A large number of routes exist and cannot be summarized. Cross-operation entity, multiple IGP running in the routing domain. IGP cannot provide tools to execute the desired policy, and the network belongs to the multiple ISP. And this is some of the consideration for us to know why we need to use the BGP. And BGP can deploy if the preceding conditions are met and the project implementation and network planning are fully considered. So let's say the user will ask, do I need to run BGP in my network? So first, you need to know that your environment today is very large and cannot be summarized. Then in this case, you might need to use a BGP to doing the route filtering or route control already. And they must involve between areas. It's not only within your environment. Then in this case, you might need to consider using a BGP. This is some of the consideration. Either you want to use a BGP or not. Okay. And when the using BGP, we need to think of the risk of the BGP. A BGP route hijacking and also the asymmetric routing. This one is when you're doing the planning your environment, you need to think of what are the risks they can come out from when you perform a BGP connection. Because of BGP connection is going out to the public, you need to make sure that this route cannot be easily be hijacked, or they can inject some of the route to you easily. So that's why the planning of your BGP is very important. How the security is defined, and also the asymmetric route can be easily happen. You need to make sure that all the symmetric route will be created into your BGP environment. But this one is pretty difficult. You need to make sure that your planning and design must be doing very well to achieve the symmetric route. Okay? And that is some of the precaution of the BGP network deployment and the maintenance. Under the multi-home AS in use in these examples, company A connect to the two AS. A route advertised by ISP1 is incorrect advertised to ISP2 because of the confusion errors. So it means that it can easily happen when I send this, you send back to the ISP2. Okay. Filter out the selected route advertised by the ISP based on the services. And pay attention to operating performance by the peer AS to prevent the local network from being adversely affected by the misoperation in the peer AS. So in this case, you need to be pretty well to define that what information need to be passing through you. Because in this case, yourself, this is on the transit already. It's a transit AS. You need to properly define whichever they learn from this are not advertising out from this ISP. So there is need to be very considered how this can be advertising. So you need to do a proper filtering policy or different attribute to control. Like whichever I come in over here, I have a tag, a communities. Whichever come from ISP1, I will not send back to ISP2. Whichever learn from ISP2, I will not send back to ISP1, and vice versa. So in this case, you need to be easily handled. Whichever they send to me, I cannot easily just send to the ISP2. So I need to do some kind of the proper planning, what type of route I will receive, what type of route I'm going to be forward. So this, they have a lot of in-depth of the consideration we need to be think of when we deal with this type of environment, especially to the two different ISP running the BGP protocols. Because when they send the route to you, based on the BGP environment, I will always advertise the optimal route. I will just easily send out. In this case, you might have an issue already. You cannot just send everything out based on the BGP environment. Is that okay? This is on the precaution that we need to think of how to deploy and how to maintain. Okay. And before we go for this optimization BGP capabilities, let's take our lunch break right now. From 11:30 go up to 1:30. So I will see you in 1:30 latest and continue with the advanced BGP and also to configure the advanced BGP lab. Is that okay? So I will just put a stop over here. I will see you in 1:30